you very much, Mr. Ho, Mr. O, and everybody from Siggraph who's been here. Very nice to invite me. I'm very excited, very honored, and it's going to be a pleasure for me to speak to you today, to so many creative people from so many different creative professions. It's one of my pleasures in life to be able to communicate with this type of audience, and I hope I can maintain your excitement and your interest for a little bit of time. I don't think it's going to be too difficult with the subject that I will be speaking about, and I hope you will let me know if I am too long in my speech.
Today we brought two of our XP Beta prototype test cars to Goodwood. But we've also brought Jensen and Lewis along to have a drive. It's their first exposure to our work. At McLaren we're very fortunate to be able to draw on a huge amount of Formula One expertise and technology, but also with Lewis and Jensen we've got two world champions helping with our test programme. It can't get better than that.
First thing you've got to remember, you've got to take your racing brain out really and put it to one side and remember that it is a road car. See, it's a nice car to drive and it feels very quick as well.
The great thing with this car is the engine and also the downshifts. I feel really comfortable. I feel the turbo's kicking in. Very good, you can brake very late and deep. It's very responsive, you know, change the direction.
I have been involved with this project from the beginning, and when you're passionate about it, and then you see someone come along and drive it quite quickly, yeah, it's an interesting feeling, but you know, we're going to get used to it because we're going to sell a lot of these cars and have to get used to handing them over to owners, and they can do what they want with them.
Sounds good.
Very good, thank you. I think you can see it's a very exciting, very passionate world that I live in, that I have the luck to to actually be able to live every day. And I will try to explain a little bit of how we achieve this atmosphere and this enjoyment of what we do every day in the development of automobiles. Most of you will already have known or have heard about McLaren. What has been very recent in our development is that McLaren is now two branches, two parts to the company. The first part that we all know of, where we've been very successful for many, many years, is the racing division. We're mostly in Formula One, but we've also been in different types of racing categories. For example, Le Mans, Indianapolis 500, Formula One, of course. There are many ways to compete. McLaren has been successful at the very high end of most of these types of racing. And since very recently, since I began, shortly before actually, our CEO, Ron Dennis, has decided that it's a major direction that we go in, which is to branch out, to become much more involved in transferring our technology towards more applicable or applicable to the industry, which is in the automotive sector. So my responsibility is directly within the road car division, which you see on the bottom. This will be our first product. So we're actually separated now in two divisions that really have a type of symbiosis between them. We use a lot of the Formula One technology in our road cars, and I will explain shortly how we actually do that, why the advantage is there. As I said, it's really a combination of joining forces. I'm sure all of you are aware what I'm showing on the screen is a very familiar symbol for you. We also take it very, very seriously. It's really the way that we are able to innovate and to move forward in such a way that we grow, constantly grow. As you see, the building itself, this is where I work, is really designed on the symbol of yin-yang. We all know what yin-yang means. It's mutually beneficial, one force, the other forces. But it's taken really to the, I would say, the nth degree, which we mean is to the ultimate degree. Not only does the building look like yin-yang, the technology center, but that lake that you see there actually helps us within the building for many different purposes, which we could explain, but they will take up a lot of time. What I want to say is that it really is important within this building that we develop a very, very positive energy to achieving our goals. I'm very, very lucky. I'm sure that anybody who's ever stepped foot inside of McLaren, inside of our technology center, has the feeling that they're either inside of a James Bond film or a science fiction film, maybe Star Trek, but actually it's a combination of the two. The atmosphere we have within the technology center is one that I can't personally, I know a lot of us feel this way, can't wait to get to work in the morning. I can't wait to wake up to get to work in the morning. And I don't want to go home. It's a bit of an issue sometimes to be able to leave the pencil or the pen or something down to skate, but most creative people work this way without the clock. I would say that 100% of us within the technology center operate that way. It's not just the creative people, but also the engineering people who work there. The center, as I explained, is very high-tech. You can see a lot of innovative architecture within the building. It's a very, very clean design, very purposeful, very, very light in terms of visibility. There are very few solid walls. Everything is crisp as glass, see-through. Gives it a very, very communicative atmosphere. You don't really feel like you're locked away from other people. You have a lot of communication facilities to go to the next person or the next department and to exchange ideas very quickly, very effectively. A lot of the building itself is developed actually by or mostly of course, by the architects Norman Foster and Associates. Personally, within McLaren, the Formula One department is responsible for what you see here. This, because we have an immense amount of glass facing the outside of the building, this causes a problem with the wind. The wind shear factor is a major force that we have, or the architects had to contend with. So the Formula One engineers actually came up with the idea of how to support the glass. It's a Formula One technology system that holds the glass straight and stiff against the forces of nature. within the actual technology center, we were able to start from the very, very beginning of the creative process, which is design, of course, packaging and design, to the very last stage of the build process. Within that process, there are many, many steps that we have to go through. One of the most exciting steps for a designer is to be in the wind tunnel. We have that facility on board inside the technology center, and it's very, very amazing to work with engineers who actually are so talented that the ideas that they have are outlawed sometimes in Formula One. We're able to apply those in road cars, and that transfer of technology is actually very, very true and very exciting to work with. McLaren, just a very little bit of history of McLaren. McLaren is, like I said, very successful since a long time in the automotive industry, is particularly in racing. The real era, I think, where McLaren really started to make a huge impact in terms of technology was back in 1981. This is the day that, or the year that Ron Dennis was brought in as the head of McLaren Racing. And what he did was set up a new direction in terms of technology and the use of aerospace materials. Carbon fiber is a material that is brought in from the aeronautical industry for the specific properties of stiffness, strength, safety, lightweight, all these things that are very precious to us. And he used that for the first time in the racing industry, and we developed our monocoque, the actual central part, the central tub of the racing cars, in this material, 1981, and successively after that, every Formula One manufacturer now and most of the racing teams actually use this type of construction method because of the advantages that it does bring. So I would say that our technology is the leading technology at the moment in terms of material usage. We had to, at some point, really try to apply this to the real world, and we did that in 1993 when we started the first road car developed from McLaren, which was the F1. The F1 currently is probably, well, for sure it's been the supercar of the 90s and also of the new millennium. And there is another car, which is not very attractive in my book, that is now maybe pushing the limits of performance at a bit of a higher level. But in terms of how this car impacted the industry, I think it's very, very unique and will mark a very important part in the history of development of automobiles. That's particularly the use of the carbon fiber. The McLaren F1 was the first road car that used carbon fiber, and to an extreme advantage, which means lightweight, efficiency. The car is purely made out of carbon fiber, and so that technology that we used to create this cell, this safety cell around the driver, when we introduced it, of course, it was very, very expensive. It was the first time we were bringing it into the industry, and of course the costs were, as I said, significant. To produce one chassis, one actual safety cell for the F1 cost relatively about 100,000 pounds. As we developed the next car for McLaren, with collaboration, of course, with Mercedes, we did the SLR. We were able to drop the price of the carbon tub down to 30,000 pounds, and significantly also speed up the time to develop this, to actually produce this tub. So we were down around 30,000 and able to build the tub in 6 days. Now, with the new car that we're presenting, this advantage of all this technology has allowed us to actually drop the price now to 6,000 pounds. That's a huge difference from 100,000. Allows us to produce cars in volume now, and it only takes us 4 hours to actually produce this carbon fiber tub. Now, I know it sounds still almost prohibitively expensive to produce this type of car. We're only using it now in the supercar range. This is almost what we call the high volume segment of the supercar range. Most car companies that make these type of cars operate in this segment here. We're the first ones that are using this technology in that segment. It's like I said, very expensive and usually reserved for cars that are £500,000 or £1 million in price. Now the advantage of us using it here, of course, is you can imagine that we're developing a range of cars that will continue to drop in price in terms of how much the actual safety cell will cost us. And I can envision that very, very soon, much sooner than most of you would expect, we will be seeing this use of technology in A to B cars, the cars that we use every day to go to work, for our wives to use, and to send our children to college. And be assured that that very, very safe technology is being used where it should be every day, for example. And I think the advantage there is, of course, that it will become the material of the future for the automotive industry in general. This tub here, by the way, is extremely light. Most companies do make it in metal, alloy, but it's quite a bit heavier. And we are actually operating with this material at around 70 to 80 kilos, which is extremely, extremely light. And the advantages, as I said, for example, are when you see the races, the Formula One races, and the drivers crash at 200 miles an hour, over 300 kilometers an hour, and they get out of the car with just a slight headache. You can imagine why that is so important for us in terms of safety and lightweight, of course. Now, the way we actually use it is we wrap the driver, we begin the design of the cars more so than I would say any other manufacturer, because it's the way we actually have to design a car if we're going to make it in this segment here. It's from the inside out. And the actual center of the car, which you see here, is what we call the monocell. And this is what wraps completely around the driver and his passenger. And that gives us the most safety you can expect in a car today. It's racing car technology, filtered down into the road car technology at a level that, okay, it's still high, but like I said, we're going to introduce it very soon to everyday cars that you'll be able to drive yourself. The car is really the MP412C. This is the car that we're currently in the process of introducing to the market. It's not on sale yet. It's being sent to different parts of the world as we speak and being introduced. And very, very, very much sold out in terms of the amount of cars that we can actually produce and sell, simply based on the technology that we've used in the car. Nobody has actually had the pleasure or the luck to drive the car yet, but over 3,000 orders have already been placed for the car. So we know that we're going to have a very successful launch of this car. Just briefly, I want to touch on a little bit of who I am, in case most of you are not familiar. My name is, of course, Frank Stephenson. I'm the design director of McLaren, but I came from a history of designing different cars from the past, and I graduated at Art Center College of Design in 1986. I was very, very lucky. One of the few students that started, that were able to finish our education there. I'm not sure if a lot of you know about the school systems, the design school systems that we have in different countries. Excuse me. In Art Center, it's back in the 80s, of course. Now there are many more colleges, but back in the 80s, I think the college that was recognized as the college, the best design college in the world was to attend was Art Center College of Design in Pasadena, very near to Los Angeles. And it was just an idea of mine to study design. I needed to do something with my life, and I decided to study car design. So I applied, and they tell you the first day that you're very lucky to be here. Usually an average of between 3,000 and 5,000 students apply for the university, for the class, and they will take only 30 students from the world. So you almost feel like you're in elite division of people or students who have been selected to start your career, your education career at the college. The first day they really give a shock to you because they say, we've never had a class with more than 10 students finish. So that means that 2/3 of you will drop out along the way. And that's very scary at that point when your first day in class is expected to have a future career in design. The fact is, when I finished, we were only 6 students. It was very, very small, but those 6 students, we're still in contact today. We're very, very good friends. We went through what you almost call a military-style boot camp. They try to eliminate you throughout the 4 years that you attend, and they're very successful at doing it, of course. But the 6 survivors are all very well known, I think, in their at their respective companies. We had one colleague of mine was Grant Larson, who designed the Porsche Boxster. Another student was Craig Durfee, who designed the Dodge Viper. Andreas Zapatinas, he was from Greece, he did the Fiat Barchetta. We had Ken Okoyama, who was from Japan. He did the Ferrari Enzo and many other very well-known cars. And we had Miguel Angel Galuzzi, who was very instrumental in bringing back Ducati with his design of the Monster, and now he's chief designer of another motorcycle company. So myself, I was involved in these cars that you see here. So we from our passion, our desire to succeed, we really drove each other very, very heavily. And at the end, I think it really paid off all this hard work. My direction immediately after finishing the university was to go to Ford and to work in Europe. I was sponsored by Ford in my last last 2 years, the last half of my studies, and they were kind enough to offer me a position when I finished the university. I really didn't want to work in the United States. They are not my favorite cars. So they promised me a position in Europe, and that's the first job that I had, which was to design the Ford Escort Cosworth. I also worked then, after leaving Ford, on the X5 from BMW. I worked on the Mini that was released, the new Mini. Then I was sent to Maranello and Modena in Italy, where I was the design director for Ferrari and Maserati. And I worked on some very, very special cars there also. Then, of course, after that I was sent from there to Fiat Group in Turin, which was a very, very critical moment in the history of Fiat, where they needed to have some products that would help them bounce back into the game. It was a very critical moment of survival, and we produced very, very extremely quickly with methods that I will show you now, the 500 or the 500, and shortly thereafter I was at Alfa Romeo in Milan, and then I got the call to go to McLaren, which for me was amazing because it's basically starting up the design language of a company with a huge reputation, and with the resources that they have at McLaren, it's really the dream job. I thought Ferrari for a designer, or Ferrari Maserati, was the dream job, and I cannot tell you how excited I am. I wish I was at work right now, but I will have to wait until Monday. We'll get through quickly the presentation. So, like I said, the first car that I ever worked on that became known was the Ford Escort Cosworth. And the very special feeling I have with this car was that I was involved with the rear spoiler that you see here. There are actually two spoilers there, one on the car, one above the car. And a very interesting anecdote was that I've always been inspired by different objects in my life, and one of them is the Fokker DR-1 aircraft. It's a World War I fighter plane. You might know it as the Red Baron airplane with the 3 wings. Well, when I started the design of this car, if it would have been for me, we would have ended up with 3 wings instead of 2, because I designed 3 spoilers on the back of the car. I think it was a German product coming from Germany. It looked like it should have 3 wings as a dramatic sports car, but when the financial, we call them bean counters, got a hold of it, they thought it would be cheaper to remove one of the wings, and we ended up with 2 wings on the back of the car. So I wasn't happy, but then I moved off to BMW. That was a very, very exciting time for me because they had just acquired Rover Group in England, which is responsible for MG, Land Rover, Mini, and some other marks that are a little bit less known. As soon as that happened, that acquisition happened, our head of development at BMW, Wolfgang Reitzler, wanted BMW to produce what they would imagine would be the BMW equivalent of the Land Rover. And instead of following the normal design process, which is to go through about a year of design development, to actually come out with your first interpretation of what the idea could look like in physical form, he wanted to see it in 6 weeks. That's unheard of, basically. It's very, very difficult to design, if not impossible, to design a car in 6 weeks and actually produce that car and have it in 3D standing in front of you. And this was much before the digital age that we all know today, where it's much easier to do it, but it's still very difficult. Basically, the car, I had to, instead of going through the regular design process The only way to actually provide it for him to see in 6 weeks was to actually go outside of Germany, from Munich, to Turin, where they have many design studios that can actually take your design and produce them for you in 3D. 6 weeks is still very, very short, but so we were able to avoid a big sketching program and a big design engineering development program simply by putting me on the airplane on a Sunday afternoon and sending me to Turin to have a company build it for us. And so I remember sitting on the airplane on a Sunday afternoon actually drawing this car that you see, and when I landed, I went into, they took me to a very small shop just outside of Turin, a modeling shop of course, but very, very small, very Italian, very chaotic. And I showed them my drawing that I did on the airplane. It wasn't on a napkin, it was on a piece of paper, but it did have coffee on the paper. And I was immediately a bit surprised because the 3 men that they introduced me to, who were going to be responsible for building the model, were each about 70 years old. And I knew that the pressure was going to be enormous to work consistently very hard for the 6 weeks. So my first question, I didn't yet speak Italian, so I asked the person to ask them, do they really think that they can maintain this 18 hours a day, 7 days of work week for 6 weeks? Do they have the stamina? Are they good modelers? And I remember the person who I was translating said to me, "Don't worry, they are the same people who actually built the Lamborghini Miura." And suddenly I realized I was standing in front of Michelangelo of the car industry, and the Leonardo da Vinci, and Raphael, for example. They were absolute masters of car sculpture, of creating models. So, to my astoundment, they worked much quicker than I could actually design the car, and it was a really learning process for me there. It was one of the greatest experiences of my life to work that intense, that passionately with 3 of the greatest car sculptors in the world. We did finish the design within 6 weeks, barely, but we did. We took it back to BMW, and the head of development looked at the car, walked around twice, and said, "That's the design, let's go into production with it." So it was one of the quickest design cars ever, I would imagine. It was from sketch to actually see the first model. Now that was done manually, and I think to do that today would be almost crazy, because if you did something that quick and had a mistake, you would see the mistake in production. So it's not really the healthiest or the most intelligent way of designing a car. But what happened thereafter was they froze the car for about a year because the cost was a bit high to produce the car as designed. And so the next program that we were involved with was the Mini Cooper. And that was probably the design project certainly of the century, and I still cannot remember or think that there could be a much more interesting program to develop a car. If you imagine BMW suddenly realizing that they have the power of the Mini brand in their hands, they can either kill it or they can keep it alive. The original Mini, of course, had never changed from 1959 until 2000. There was no design changes. It was pretty much the same car. And usually a car in its lifetime will develop an evolution. It will look modern at some point as it goes through its evolutionary process. Because the Mini didn't have that, it was reaching the end of its life, and it was going to be taken out of production in 2000 because it didn't meet legislation rules. And the challenge then, BMW said, was how do we create or how do we recreate the Mini from the 21st century? And so, how does BMW, as a German company, reproduce a British icon? Of course, the English people were very upset that Germany was actually responsible, or BMW was going to be responsible for this project. It was a little bit like taking your heritage and giving it to somebody else to interpret. So already the tension was built into the project. When you think that it normally takes 3 cars to determine what the new car will look like, 3 basic themes, full-size themes, that are looked at, selected, and evaluated to be the new car. If you're a major car company, a huge car company, for example, I don't know, Hyundai, Toyota, General Motors, they will produce perhaps a maximum of 5 designs, 5 different models to look at. And that is a large number because each design has to have its own engineering team dedicated to it to make sure that the design is feasible, is doable. BMW in its preoccupation or worry that they had to really find the right design for the new Mini decided to break the bank, to forget about the budget, and to produce 15 new proposals. So the way they did that was they asked 5 designers in Munich at BMW, 5 designers at DesignWorks, which is a BMW division in California, sort of the fun side of the market, 4 designers from Rover Group in England, and 1 famous Italian designer in Turin. And he asked them to provide, all of us to provide individual designs for the new Mini. Of course, each designer had to be in isolation, so we didn't cross-contaminate our ideas, so that each idea was very unique and looked like the designer intended it. We had a free white paper carte blanche to design what we interpreted ourselves as the new car. And of course, when the day of the presentation came, it was a very exciting day to see what the 21st century Mini could look like when you had to look through 15 separate designs, all lined up in front of the executive board, sort of like a fan laid out so that there can be a progression of designs. Very interesting to see that perhaps the ones towards the left were almost as if the designer had slept for the 6 months. We had 6 months each to develop the car, and had woken up in the last week and perhaps just only grew the car, the original car, 120% and created their vision of the Mini. Whereas the other extreme on the right side was we had trouble determining if it was a Mini because we don't know what the designers were smoking for 6 months, but it definitely was not something that looked like a Mini. Right around in the middle was the car that I designed. My approach was a bit unique, which I don't really understand still to this day why. I did it in the most logical way I could imagine, which was to take the 1959 Mini and spend 1 month working on what it should look like for the 21st century, which was the first week I designed the 1969 Mini, the second week I designed the 1979 Mini, and successfully that way until the 4th week when I designed the 1999 Mini. So I had sort of a very evolutionary succession of designs that led me up to what I thought that the Mini of the 21st century should look like if it had continued to evolutionize throughout 40 years of development. So, in other words, when they say today that the Mini is a retro car, my blood boils because I don't see anything retro about the car at all. It's really new technology. A lot of the things that we introduced in the design were impossible when I designed it. The amount of glass, the type of bonnet or hood that actually extends as one piece, lamps in the back. There were a lot of individual things that were really going to give headaches to the engineers in terms of how to develop them. So the car really was never intended to be a retro car. I know that's a new buzzword that goes around saying that retro cars are here and there's a lack of creativity, but it really wasn't the case of the new Mini. And I think this type of design is sort of what you would see, for example, today in the 911, the Porsche 911, where you can see the original 356 was the original 911. It changed every so often. It had its years of development, and today the new 911 has a similarity, visual similarity, instantly recognizable as a successor to the 356, which was much earlier. And that is very similar in terms of evolution of all of us. For example, I'm sure that all of us have traits today that we can still see in our grandparents or great-grandparents. Not everything, but of course we're larger, we're stronger, we're quicker, perhaps hopefully more intelligent, but a lot of the traits that you see within people today, you can actually see the evolution from a few generations back. So that, for me, was always the logical way to design, was to carry it forward progressively like that. One very funny instance that happened for me during the development of the Mini was, you can imagine that before this show where we had to present the 15 cars all together, we're working in a very, very close atmosphere for 6 months with your team of modelers, so we get to know each other very well. What happened on the very last night, just before the presentation, was, and of course there's never enough time, even if it's 6 months, there's never enough time. So for the last week, we were working 24-hour days and on 2 shifts. So very extremely tired, but the emotion was there, the excitement of finally arriving to the finished design was there. We felt internally, our team, that we had a winner. We of course didn't know what the other people were doing, but we were thinking if they'd done something, if they have managed to make a Mini that looks better than ours, then more power to them, respect, because we felt we had something very, very special in our hands. This was October 1995, so quite a few years before the car was even launched. So the presentation was going to be on Friday morning at 10 a.m. and it was 4 a.m., slightly before, and we were just finishing the car, so since about midnight we were already celebrating, and I don't drink, but my colleagues did, and they were quite happy at 4 in the morning, but also very useless, incapable of working. So I wanted to make one last look and make sure that everything was perfect with the car before we sent it off and finished it and left it for the show. And I needed to go home and get a few hours of sleep before. So I walked around the car to double check that everything was ready to go. And I froze behind the car because suddenly I realized that the car was lacking an exhaust pipe. Now, an exhaust pipe normally is just a tube out the back of the car, but in the Mini's case, it's a very, very special, especially with the original Mini, it's a very, very special piece of design. And it makes a very strong statement to the car in terms of its performance and capabilities and such. So I was looking at the car feeling like we actually forgot to put something very, very important of the design into the model. So I approached the chief modeler. I said, Colin, we made a real bad error. We haven't remembered to put the exhaust pipe on the back of the car. And he looked at me and he said, look, it's just an exhaust pipe. Nobody's going to even realize it. And it's 4 a.m., 4 in the morning. And I'm not going to start making an exhaust pipe for you at this time in the morning. And the other guys, they cannot work. They're flat on their backs. They're really, like I said, useless. So, and he was drinking his can of beer, German beer. And I had to make a quick decision, which was I have to make the exhaust pipe myself. So I took his can of beer, I should say Coca-Cola, or pop drink or soft drink. And if you all know what a Coke can looks like, or a soft drink can, it's the same. It has a nice section on the bottom of the can. They're all very similar. So what I did was I cut half the can off, the top half, and threw it away. Took all the paint off the can. And what I had in my hand was a silver-looking object. I put on the bottom a hole inside the bottom of the can, and then we put it into the clay, and we stood back, and our jaws dropped. We were amazed at the most beautiful-looking exhaust pipe we'd ever seen in our life. It was like a bit of over-design. It was incredible that somebody had actually put that much effort into designing an exhaust pipe, and at the same time, it looked really, really good, very, very nice. So what happened was the next day when they went through the design selection, my car, as I said, was the one that was chosen. So I was receiving congratulations from different people. And my boss, the head of director of design, was Chris Bengal at the time for a long period. Chris comes up to me and says, Frank, congratulations for your design. You will have an extremely busy next 5 years to put it into development, and it's good for your career. But never, ever, ever waste another man's time, a modeler's time, making such a detailed exhaust pipe. And what I was embarrassed to tell him was, of course I didn't say anything. I was thinking, how can I tell him it only took me 4 minutes? And it was a beer can. So I said nothing. So eventually, a couple of years later, the supplier who actually makes our design exhaust pipes came to me and asked me how I wanted the design of the exhaust pipe to be. I said, or I thought, as long as he's asking me, I'll just have to show him the exhaust pipe that we put on the car. I showed him the can, and they made it. And if you look at the Cooper, the original Cooper that came out in 2000, and you look at the exhaust pipe, you will see a Budweiser beer can hanging off the back of the car. That was desperation, not design, but designers have to be ready in any case to pick up something from wherever and use that as a solution. So that was one of the ways I was able to give a lot of character to the car and to maintain that emotion of the past with the technology of the future in developing this car. The Mini gave me a bit of recognition after the X5, so I started to receive a lot of phone calls from other manufacturers around the world, but I was really not ready to leave because Mini was going to grow into a new family of cars, a big range of very exciting products, and it was already on the road to success. It was received very positively around the world, and I thought, well, what better place to work than at BMW creating the new family of Minis. But I received a call one day from a lady who was representing, she said she was representing another company, and asked me if I would be interested in working for a high-end manufacturer in a very high-end position. And of course my first question is, well, who are you, or who are they? And she said, I cannot tell you, but if you accept that we send you an airplane ticket and you come to interview with us and we think you're the right person, then of course we'll tell you who we are. And I thought, okay, I can't lose anything if it's just one day. I'll just take one day out of work and see what happens. Like I said, I wasn't ready to move. I was really thinking there is no company in the world that can attract me more than BMW at the moment with the Mini project. Then the ticket came, and it was to fly to Turin. Now, I don't know if you're aware, but Turin is like saying Fiat. It's the same as Fiat Group is Turin, basically. And when I saw that, I thought, why would I ever want to go from BMW to Fiat? That's really, not something that I would ever aspire to, especially because of the situation at Fiat and such. But I said, well, you never know. It can be something very special. It can be maybe to create a new division, a new studio, whatever. So I'll just see what happens. And I went to Turin, to a meeting place that we agreed on, which was a very small Italian restaurant. I don't know if you're aware that in Italy, from the outside, you might just see a very small, cracked, old door, and you walk in, it's perhaps a five-star gourmet restaurant inside, so you can never tell from outside where you're going to be eating. And the food, of course, in Italy is absolutely the best in the world, I would imagine. So I was in there waiting, and of course, two senior executives that I recognized from the press came in and sat with me. One was the chief designer of Fiat, and one was the technical director of Fiat. And I was already not feeling very positive about the meeting because I was already, like I said, happy and not really looking forward to change, but open to what they said. Basically, during the interview or during the lunch, they just asked me to give my opinion about design and what I thought about the future and such things. And it was very, very good, very entertaining lunch, but I thought, this is not really the job for me. Until the dessert, and I was eating dessert, and they finally said to me, we think you're the right person for this job, and we'd like to make the offer to you, and if you accept, great. If you don't accept, please don't mention this position to anybody else, because it's not open for people to know about it. And they said the design position that we're offering is to be design director for Ferrari and Maserati, and I cannot tell you what I did with my food then. It was basically, and I was very shocked because I thought, and I said to them, that can't be true because Ferrari and Maserati do not have a design director. And they said, yes, exactly, that's why we're asking you, because we want to have internally at Ferrari and Maserati somebody who can represent us in terms of the work that we receive from Farina, who historically has always done the designs for Ferrari, or Giugiaro, who's done many, many Maserati designs, and they wanted to have in-house somebody who could actually give feedback or input or control the design. So I asked them, where do I sign? And from that day on, I was probably the most excited person in the world without being able to tell too many people about it. And I was really looking forward to moving to Italy and to living each day as if it was Sunday. I think that's the best description of Italy. It doesn't feel like a day of the week, it feels like a weekend when you're even during the week. Of course, so that was a very, very exciting time during the beginning of my design career. I was spending the morning at Maserati, and in the afternoons I would go to Ferrari, which was only 18 kilometers, about 11 miles down the road, and spending that time. So that really for me was like the limit of design for a designer to have that kind of position where you can actually design cars for the future for two of the most well-known supercar manufacturers in the world. I love supercars, and that really for me was the kind of design that really I inspired to as a child. I was always having posters of cars like these on my walls in the bedroom. This, of course, this is just a design that I made at some stage when I was in Ferrari. This could have been a Ferrari, it's not, that's why I'm showing it to you. It's just one of the ideas of a Ferrari that combined a lot of, for those of you who know Ferrari well, I'm sure you'll recognize many elements of past Ferraris inside this design in such a way that it still looks modern, but it carries a lot of elements of the of very well-known Ferraris from the past. And like I said, you have to respect the heritage of the company that you're designing for. It's very important to not be too selfish or too singularly in your direction of what a design should look like. You should really, I've always tried to really study the history of the company and tried to expand on those emotional values that the companies have in their history. What happened thereafter was, very briefly, I went from Ferrari to Turin. I'll go back one slide so you stay on this one. When I left Ferrari, it was not for my own choice. That sounds sad, but it wasn't. I was actually sick on a Friday night at home. Ferrari is so small that if one person catches the flu, everybody catches the flu. So a lot of us were home that day. And I received a call that evening from Luca de Montezemolo, who's the head of Ferrari, my boss there, asking me how I was feeling. I said, I'm not very well, but you know, what do you need me for? I can do something if you need it. And he said, no, just relax, have another cup of, or a glass of champagne, you're going to Fiat. And my first reaction was, what have I done wrong? And I felt completely like I was being cast out of heaven to go to hell. And he said, no, it's okay. They're developing a team at Fiat that has to really resuscitate the company, bring them back to life as quickly as possible. They have a lot of problems with their products strategy at the moment, and we need you to create a successful product as quickly as possible. So I was sent to Turin, and the first project that we worked on was the Cinquecento, the Fiat Cinquecento. And that again was very, very similar in development to the Mini, except that I had already learned quite a bit in how to develop I think a car with that emotional content and with the technology, the future content that I spoke about. And so it's fairly easy in sort of thinking, what should the new 500 represent? What should it look like? How should it connect to the people? It shouldn't be purely masculine or purely feminine. It should really become a car for all people. You should have many accessories available so that it can be very basic. At the same time, it can be a very unique, accessorized car. It can become an extension of yourself. Many people have cars like these and they actually give them personal names because they almost become part of their character, their family. But of course that was a process where we had to work extremely quickly. We developed the car from where it was at as a show car to production within 18 months. And normally it's a 3-year process to develop a car from the first sketch until where you can actually say it's ready for the road. 3 years, this car was 18 months. So that was really one of the first records I think that we set in terms of actually preparing a car for the road. We did use a lot of digital technologies to arrive there. Without that, we would have been lost. We never would have reached the deadline. We would have had a car that arrived at the market too late to help the company. So we had a fairly large amount of input from the digital side. And like I said, I'll speak about that shortly also. When I was at Alfa Romeo, after we, as a big team, large team, we finished the Cinquecento, I was sent to Alfa Romeo pretty much for the same purpose, which was to create new products for Alfa Romeo in a time where the strategy was lagging, I would say, in terms of what they were offering the market against the competition. And there needed to be a fire set to Alfa Romeo to stimulate it, to make it exciting again as one of the major competitors in that segment, sports car segment for sort of the mid-range buyers of those types of cars. But what happened then was, because Fiat was very, very much concentrating on reviving the Fiat and Lancia brands, the mood at Alfa was a little bit slow and conservative. And I think as a designer, that's probably one of the things that really bring you down the most, is when you're not allowed really to stretch your creativity and to sort of take the brand into the future. We were being held back in these design phases and development phases, so it was almost like going to work, but not really being able to contribute anything to advance the design philosophy of the company. So it was, although my father was a huge Alfa Romeo fan. I grew up with Alfa Romeos since I was a child. Always we had Alfa Romeos in my father's garage, and so I loved the brand. I knew about the history. I loved the whole essence of what Alfa Romeo stood for, and I thought that the opportunity to work on it was going to be the next most exciting thing I'd ever done in my life. But a little bit of frustration was there, and then, as usually happens in these type of situations, there's always a silver cloud, and a silver lining in each gray cloud. The opportunity suddenly came up that from a call that McLaren was concentrating on opening up a whole new automotive division, and they would have to create the base of it right from the start, the executive base and the teams and everything involved in creating a brand new brand or mark. So I think McLaren, having that reputation already as being very, very successful in terms of engineering and development and racing, when they called, it was almost as if when Ferrari called, it's like when the Pope calls you to Rome, you don't think about it, you go. And when McLaren called, for me, the idea that I was able to, or was going to be able to create a whole new design language for our car company, to start from scratch, right from the beginning with a white sheet of paper, and to create the look of the very first new McLarens was absolutely irresistible. I had no qualms, no hesitations about going to a brand that didn't exist, because of course they weren't just going to repeat one car again like they did in the 90s with the F1. This was to actually create a whole brand of cars, a large range for that segment, and each one was going to be different. There was a very planned product strategy for the future, and I was going to be part of that amazing development team. So I don't know if there's anything higher than heaven, but that's exactly how I was feeling when that call came through. And I actually met with the people at McLaren and learned that these people are not your normal type of automotive engineers. They're at a bit of a different level in terms of how they think about developing cars. The McLaren, of course, when I speak about it, it's very excited tones, because we're using racing technology to build this car, and that's really a first in the sports car segment, because although other manufacturers can say that they have racing heritage or that they're directly influenced from racing, their cars are not as don't benefit as much from racing technology as the products that I see coming out now and in the future from McLaren. It really is a Formula One team developing a race car, and the reason that that applies here a little bit is because of the way they actually apply their technology to building a road car. It's nothing like what is done in the automotive industry today. The development of a car, I told you, is 3 years. If you can imagine, a racing car during the season has a minimum of 300 changes per week before the next race. The engineers are constantly changing, updating, improving the car week to week. And automotive engineers thinks in much larger time spans, does not have that advantage that we have in Formula One of amazing computer technology and computer graphics and visualization techniques and simulation techniques, and everything that helps you to be able to accomplish these minimum 300 changes per car per race. So that's what makes this job for me absolutely the top of the top of being able to develop a car from the very beginning. This is not really about cars, but this is my first car here. I was born in Morocco. My father and mother are from different countries. I just want to bring you slowly into why I think a little bit, maybe not differently, but in a very open fashion. My background is is quite a bit different than most people because my father, being a pilot, we moved around the world quite a bit when I was young, up until I finally settled to where I am now, of course. But this type of vision, I think, is really necessary for a designer to be very free in his way of thinking, very unprejudiced, receptive all the time, open to change. As soon as I left Morocco, I was born, like I said, in Casablanca, we moved to Istanbul. So what I did was grew up in an Arab atmosphere with parents from 2 different countries, and spent my first 11 years not really knowing what a car was, more so about donkeys and camels and basic roads and things like that, almost a third world type atmosphere. So my car interest really didn't start there. We spent a little bit of time in Istanbul, so I was able to pick up a little bit of the language there. A very, very artistic, creative environment also. When we left Istanbul, we moved to Madrid, where I was able to finish my last 2 years of high school at an international school there. And I really, really did, when I was younger, want to become a bullfighter. It wasn't really the safest profession, but it was one of the most artistic and one of the most exciting for me as a child there. I really loved the artistic side of it. I know it's not a really favored or appreciated art. I don't call it a sport, I think it's more art, but it really does bring out a lot of the emotional potentials of a person, how it reacts in face of danger. There are very, very many exciting aspects about this. But of course, when I finished high school, I had to get into something a bit safer, and I started to race motocross. My father already had a car business in southern Spain, which was to sell Saabs, Rovers, Minis, SEOULs, different cars. But I got involved with racing as soon as I was out of high school, and I progressed fairly quickly. I was the junior champion and senior champion in Spain before I moved up into a super license, which is professional, and then I was able to race professionally for 4 years. Then, because my father is of the nature of a person who says that second is the first of the last, if you're not first, you're second or less, and that really isn't the way to be in life. He demanded absolute perfection to the extreme. My father was probably, I mean, I respect him as much as anybody can respect a father. He was very, very hard to please, but I think that helps you as a child when you're growing up to really perform as high as you can in anything you do. When I wasn't winning at motocross, I was good, but I wasn't the best. He recommended that I either start to work or I go off to study something to become something in my life. By the time I reached 30, if I would have stayed in this profession, I probably would have been okay, but burned out by the age of 30 and really not moving anywhere in my future. So I went off to Los Angeles. This is not me, but this is what people do in Los Angeles. I regretfully, in the 4 years I spent in Los Angeles at the Art Center College of Design, I never saw the beach. I was only an hour, half hour from the beach, but like I said, the pressure at Art Center is so intense that if you get sidetracked, you immediately fall off the track, the rails, and you lose that momentum. So it's nice to look at a picture like this, but really I was almost in prison for 4 years. After I left Art Center, I went to Cologne, where Ford was located, and I worked in Cologne, Germany for 5 years. That was for me one of the best places, I think, in the late 80s to learn about car design and use the new tools that were starting to come out, the digital type tools that everybody, or most of us, take for granted today. And Ford had a very direct access to that type of training, that type of implement of our tools. So I was in designer heaven when I was starting out at Ford, able to start using these methods to provide our designs. Then, when I got not tired of Ford, but the problem with Ford was I was designing what we call bread and butter cars, mass heavy volume cars, and a little bit of excitement of the design process is lost when you design a beautiful, beautiful car, and then somebody comes along and reduces the actual cost of that car to something that you don't even recognize. It's almost as if you take your child, allow somebody to change their clothes into something that you never thought your child should be wearing, something not as nice. So it's a very, like I said, emotional connection, but you want to aspire to something always better. So I moved to BMW and I worked there in Munich. And then shortly thereafter I moved to Maranello, which is where we make the Ferraris and the Maseratis. And of course the food is incredible. I put on so much weight there. I'm embarrassed to say how much, but the combination of food, culture, all those things were really making that period of my life very exciting. Then I moved to Turin, and like I said, that was another period where more than anything else, it was just working under stress to produce designs very, very quickly and successfully. Then in Milan, of course, with Alfa Romeo, and then London, where we do the McLarens. I'm very sorry about the picture of London. This is the best day that I could find in London. We never see the sun, so it's a good day here in this photograph. Then, what I want to explain a little bit is how we actually are able now to design cars in not even half the time, but much, much less than half the time, and what usually is the industry norm today. We have what we always consider or many companies still use it, which is the traditional design process. And the traditional design process, if you're not familiar with the automotive world of how we actually create a new car, a brand new design, starts as basic as you can imagine. We start with sketches. It's a 2D sketch on a piece of white paper. Lots and lots of ideas. Not just one, but as many ideas as you can put out very quickly. And then we go to a phase where we actually have to select which are the better ideas, which are the lesser better ideas, and eliminate make a finer selection of what's the correct direction for the car. Then we go into a clay modeling phase, and this clay modeling phase is based on that drawing that we think is the right direction for the car. Then when we actually have a clay model, usually it's a scale model, it can also be a full-size model. Then we take that, we decide which of those clay models is the correct or best suiting design for the car. Then we take a digital apparatus and we scan the car, and then we produce it and we release it to engineering. And they take the car, and that's where the trouble begins. What we do at McLaren is, this slide here is what is normally done. You leave the engineering almost to the very last point, and then the engineers, like I said, have a very, very difficult time to produce the design, because the separation between design and engineering is left a little bit too late in the program. I'm sure you see concept cars at the motor shows, and when the actual car comes out, you're a little bit disappointed that the concept car looks so exciting, so striking, and the actual car is so normal and not as exciting. That's very, very much due to this process here. What we do at McLaren is we have a completely different process that I've tried to instill right from the beginning when I started, and that's to keep pretty much the same type of steps that we have to go through, which are necessary. You need a physical, full-size model to actually evaluate. But what we do is we incorporate engineering right at the beginning, and I know a lot of you in the creative profession are thinking that's not good because it will stifle or hold back the creativity of the designers and not allow them to be creative enough. Usually we let the designers stay in the studio for 6 months to dream. They go home, they dream, they sleep, they dream, they wake up, they go to work, they dream. So they're constantly dreaming up beautiful, beautiful designs. And when they finally present it to the engineers get very angry because they think, you're crazy, you cannot build this car because it's impossible. Then you have a lot of conflict. If you incorporate the engineering right at the beginning, and the secret is that the engineers have to be as creative as the designers. When you have an engineer who is very limited in the way he does cars, in other words, he's thinking about the budget, he's thinking about risk, he's thinking about timing. These factors make him very resistant to change or to innovation. At McLaren, like I said, our engineers are not automotive engineers, they're race car engineers, and they basically are as crazy, as creative, as wild, as excited as the designers that we have. We have very very few designers, but also very, very exciting, very talented designers. And to be able to match that engineering input to that kind of design input is absolutely the best formula for design, not only car design, I would imagine, but for all types where you need to combine design and engineering together. So what we're doing is actually from the very beginning, working extremely creatively, and combining engineers together so that what we actually design is able to be produced. We're not missing 6 months of engineering development. We're bringing that right in from the very beginning and making sure that we bring out ideas that, okay, they are challenging for the engineers to develop, but they're the type of engineer who looks at their watch at 6 o'clock in the evening and says, you know, in the automotive side, they would be thinking, I have to go home. My wife is waiting for me. My children is waiting for me. I have to feed the dog, and I have this type of responsibility. Whereas the automotive racing engineer relishes, he really enjoys this type of challenge. So I think the secret of McLaren is that we can be really innovative with this type of team, working very, very closely together. So what that results in, the very first product that you will see the result of this type of cohesion, this type of interaction of design and engineering is what you see here. This is the MP412C, and like I said, this car isn't on the road today. It will be appearing, I think, in about February or so in the magazines with tests and slowly being released to the customers and to the dealerships around the world. And it's a very, very exciting car because pretty much, like I said, we started with the design process of sketching, but what we did was accelerate it very, very quickly from the design sketch phase into what we call digital modeling with the engineers. So this car was pretty much at the very beginning of the design phase, within a couple months, already in such a digital phase, and such that the engineers could actually give a lot of input and calculate and determine all the benefits or all the negatives of the design. Then using what we call our power wall, it's sort of like a mini theater. It's the workhorse room of the design studio. It's where we actually spend most of our time in terms of evaluating and testing and trying things that without the digital phase or era you would never be able to do. We experiment with colors, we try cars in different styles, we try looking at just specific points of the interior for quality reasons. Every accessory can be done digitally and put onto the car, and so we're already getting to know what the car is going to look like before it actually is built. When you build a car, you run the risk of the paint not being correct, the modeler being sick and you miss the deadline, too many confusing inputs from different people who have the responsibility of deciding what the model should look like. So when we work with a digital model, we're very, very few people. We only need basically 1 or 2 people to construct a digital model. A physical model might need anywhere between 5 and 10 people working on it. The results are never as accurate as if when we are working in the digital phase. And then the extent of change that we need to experiment with is very easy. If you have a physical model, you have to paint it. It's only one color. And with a digital model, of course, we can test all types of finishes, all types of colors. We can easily change proportions of the car, environments. Everything is manageable with this type of design. So that really is critical to get into that phase as quickly as possible. The only problem is that when you do a car digitally, it never is exactly as you imagine when you physically produce the car. We have to go through a phase of a little bit of animation, which you can't do with a physical model, of course. We have to do that digitally too on the power wall, which allows us to actually move elements. This, for example, is the rear wing of the 12C that actually is organic or alive. It moves constantly with the car. But we can actually present digitally to the board of directors. We can actually show what the car will look like before it's produced as a physical model. When all that is agreed on, then we go into the very last stage, which is the clay modeling stage. And there we actually produce a model very, very quickly because we already have the digital data, and we can actually let the machines make the model for us. we don't have actual physical people creating a model out of clay. We actually go into a machine-operated technology that takes the digital data of the design, translates it to a physical model. Then if there's any retouching necessary, any adjustments necessary, we can do that again on the computer and reintroduce it into the clay with another milling session. And always the clay modelers are there on hand to physically change anything slightly if you need it, but no major changes are usually needed as they are done in other parts of the industry or the older type of design. When this car is finally finished in the clay phase, which is a very, very short phase, we build our first prototypes, and we're actually able to get into those prototypes and feel what the car will actually feel like before it's in production. And that's the phase actually where we can catch a lot of mistakes also. So this whole process is much, much different than what we were doing about 5 years ago. And regretfully, a lot of car companies still work in the non-digital phase today. What's the future? I think I know what the future is. I definitely know that I think what we're going to move in is not so much 3D. The future of car design must be holographic. And I know it sounds like I'm speaking about science fiction here, but this technology does exist. And a very quick story. Last year, in the summer of last year, I went to a small business in London who are specialized in doing holography, and I asked them if they could show me what the status or status of their latest technology is. They showed me a video of Richard Branson doing a promotional thing for Virgin. And regretfully, at that stage, it was almost like looking at something from Star Trek, where the image was a little bit fuzzy, a little bit hazy, not overly convincing that it was a real object in front of me. And I said such. I commented on this, and they said, well, don't worry, we're actually still continuing to update our technology. And by December of the end of this year, of last year, 2009, we want you to come and see how far advanced we are. So I went back at the end of last year to the studio in downtown London. It's actually the ex-recording studios of a group called Deep Purple, a very, very good or bad, depends on how you look at it, rock band from the 70s, but there was a lot of good creative karma in this area. And they took me into a small room, very small room, with a couch, sofa, and a couple of chairs and a stage with some velvet curtains in front. They sat me on the sofa, opened the curtains, and I was looking at a young couple, mid-20s. They were smiling, and then they started to dance, and modern dance. And so I thought it was a very nice show. And they stopped and looked at me, and the gentleman next to me from the studio said, okay, now tell us who is the real person and who is not the real person. And I could not tell him exactly who was real and who was not real. I walked up very close, still had the stage in front of me, but about 3 meters away, and I saw the pores of the skin, I saw the small hair on the skin, and I walked to either side, I could see behind them. The lighting was perfect. The lighting moved with their bodies as they moved. The shadows were perfect. I literally could not say who was real and who was not real. It conflicted with the way I was thinking. I was thinking, if I can see that they're not real, I will notice it. But it was impossible. He let me onto the stage, and to prove it, he said, put your hand through the girl. I thought she was the real one. He said, no, she's not the real one. So I put my arm through her. It disappeared from my elbow to my wrist. I saw my hand come out the back of her, and I thought, this is the strangest sensation I've ever seen, because your brain does not think that you can actually go through a physical object like that. And I thought, this is really the way forward. If we can actually bring this into the design world for us to use more than just for promotional purposes, we use it actually for physically or virtually designing a car, where we don't even have to build the car now. We can actually just construct the car extremely quickly digitally, and then instead of projecting it onto a screen or even having it projected in 3D, which is still quite limited. I know it sounds like breakthrough technology when we speak about 3D TVs and such, but that really is still very limiting. There's always a factor of not real or irrealism to it. The hologram technology at the level that can be delivered today or at least from this company, is extremely convincing. And I was thinking, if we can produce a car full scale, project it in front of us, and we've done this already, you can actually never even have to build the car. And of course, the reason for that is because if you look at something on a 2D screen, or even as a 3D object, you never get that infinite perspective viewing angle that you need, or that you have when you look at a physical object in front of you. Whereas the reflections on a surface that's done with a hologram are exactly the reflections that you would see, and the surfaces are doing exactly what they would do in a normal lighting situation. Now, the only disadvantage there, of course, is that designers like to touch and feel, and so I think the technology is going to have to develop even further than that to give us the absolute ability to touch the surface, to feel the surface, because that is what takes the sort of the mechanical feel away from the car, and still contributes to give us the man-made, or made by the man or massaged by the hand sculptural feeling of a car. If it's too digital, you will see it immediately also. Now, briefly, I just want to say who I think are the real designers of where we are, or where we've come over the ages. Designers are not just people who sit down behind a desk and design. They're actually people who envision, almost as if instead of calling somebody an engineer, we would call them a visioneer. And for example, Alexander Bell, who was able to think of something that didn't exist and created something that was, okay, maybe not the most beautiful object at the beginning, but it was at least the start of a potential for people to come forward and to reach what we have today in terms of telephones and communication devices. Alexander Bell is probably one of the leading persons of the generation of his time, when he was able to come out with a product that everybody today has. I'm sure that there's very, very few people in the world without a cell phone. Even in deepest Africa, it's one of the tools that most people have today. Steve Jobs is one of my heroes of design. He has a great team, of course, around him also, but he's responsible for allowing such designs to come onto the market, and all of his products that are coming out of Apple are very, very design-driven, very, very exciting products to own, almost designed for less, no over-design, extremely wide variety of products that do a combination of tasks that we consider today to be absolutely necessary for our daily lives. James Dyson, I don't know if many of you have heard of him. He's very famous for his vacuum cleaners that he developed, which don't need bags, but he's not a one-hit wonder, as we call it. He's actually come up with many other ideas, and one of them, which is one of my favorites currently, is the bladeless fan. This is a fan, I'm sure most of you will know it, but it doesn't have any blades, and it makes very little noise, and it's very effective in the sense that it actually takes air in along a very, very thin edge on one side, and pushes the air out 15 to 16 times faster out the other side. So it's extremely efficient in terms of practicality. It looks stunning. I mean, I would just buy this just to put it there and not even use it. But of course, the use is combined with the design, so that's what makes it really an interesting piece of design. Truth is, this technology is not new. It's existed for over 50 years, but he's been able to combine it into a usable product in terms of what we need as a daily use thing in our lives, where we usually have fans that collect dust, make noise, are not so versatile. Then Ross Lovegrove is my absolute favorite product designer. There are many, many, many good product designers around the world today. Ross Lovegrove for me is extra special because he designs with an element that for me represents what I think is important about design, and that's less is more. He looks back to nature as his inspiration. He designs things in such a way that they absolutely don't look like they're strong enough, but they are, and they're actually even stronger in the way that he designs them. And he's always innovating. He's constantly on the edge of design, looking for things that allow him to design in such a way that the products that he does are very, very unique and just bring complete advantages to the product that he's designing. Frank Gehry is the only architect designer that I know who cannot draw. He's not really very, very good at drawing. His mind is incredible, and I'm sure if you ever see the Guggenheim museums around the world or any other architectural building that he's been involved with. It's almost shocking in the way it's been interpreted and designed. He takes his scribbles, these scribbles like this, and develops shapes that work together in such a way that a normal mind could never think like that. We don't think about combining metals and shapes in the ways that he's capable of doing. And I think just for that amount of creativity that he holds, I think he's a very, very special architect. Briefly, to go back in history a little bit, in terms of car design, we wanted to move ever since we started walking on two legs. We wanted to become a little bit lazier and a bit more quickly. So we started to use other things to get us moving, and we learned to use animals to get us to move forward. It's it sounds basic, but it was probably the first step. When somebody did it, was probably the most modern thing anybody had ever done, was to get on an animal and go forward and let the animal do the work for you. Then we got a little bit more intelligent and we designed the wheel. When we designed the wheel, we were able to turn it into something that could transport us with a little bit less energy, but we're still moving forward, and became almost an element of fun to it. Then, of course, we couldn't use our feet to propel us, we needed an engine, and Otto Benz was the person who was actually able to develop the car as a product that would actually move you in a bit of comfort and under a mechanical influence. Then Henry Ford was the first man to make it actually practical. He developed what we call the assembly line type of production, where cars were able to be turned out in high volumes as long as they were black, he said. But it put families on wheels and started making transportation much more accessible to people around the countries, and roads started to be developed, and different types of professions needed to keep the automobiles on the road were developed, so it became its own industry and its own profession in its own right. Then we started to think that actually, if we're designing cars, there should be an element of beauty added to it, because they are products that you live with on a daily basis. So we started to develop beauty, or combine beauty with these products. And this, for me, was really, excluding what we can do, of course, on computers today, this, for me, was the very artistic period of car design, back in the 40s, 30s, 40s, 50s, when cars were really designed to be stunningly beautiful. You almost wanted to spend your whole day washing this car just because you could feel the surfaces, and the chrome, the embellishment was really more of almost Art Deco in some senses, but also very, very creative in terms of use of materials, just trying to make a real statement. So this is a Figoni Falaci Delahaye, for me, one of the most stunningly beautiful cars ever produced. Then we got a little bit sidetracked with science fiction, I think, and we started thinking about what if we turned planes into cars, what would they look like? Opulence, waste. We didn't care, if the car was really harmful for the environment, or if you hit somebody, it would kill them instantly, or it took up a lot of space on the road, or used a lot of the world's resources. The important thing was to create a reaction and to just create a style, dramatic style, and push forward car design this way. But then again, we started thinking, wait a second, we want to be actually emotionally attached to the products, so we started making sensual cars. This was the era around the late 50s, the early 60s, when sculpture was becoming much more important in car design, surfacing and aerodynamics and such. This, for example, is my favorite car from the past, the E-Type Jaguar. This, along with the D-Type Jaguar, which preceded it. But the Jaguar was basically a car that was designed to be aerodynamically efficient. And so it looks like it's aerodynamically efficient, and it also looks very, very sensual, very sexy in a way. It really creates a first emotion in anybody who sees it as something desirable. It's because it's very naturally formed and very, very attractive, I would say, in many ways. Then we started to think about safety, and about cars should be more responsible, more environmentally friendly, and this is what we started to do. We started to do tanks and very solid blocks of cars that took all the emotion away, but you were actually feeling very, very safe and protected, and they weren't actually that safe as we are today, but it was more of a responsible era of design in the 70s and beginning of the 80s and such. And if you can actually imagine that somebody stood behind this product and said, wow, she's a beauty, let's build it. Find it hard to do today, but it shows where the mindset was at. Later in the 90s, we started getting back to what was actually emotional side of driving cars, and why people actually drove cars. That was to create almost an adrenaline rush, something that you really, really felt excited about owning or driving. The F1 here is McLaren. It's an extreme example, of course, because we didn't build that many of them, but it is the direction that cars started going into, which was add performance and design together and create very, very, very special products for enjoying cars. Now, what I said before, what's the future? Is it this? This is what designers would have told you probably in the 50s and the 60s, that by the year 2000, we would be flying our cars. Very, very difficult to imagine because, you know, accidents do happen and these cars would have to be absolutely safe-proof or fail-proof if we're flying in the volumes that we travel in cars today, the amount of cars on the road, if you imagine these in the air, it's probably going to be a very hairy situation. But is the future something like this? At McLaren, we're looking at what the future is today because it's very important for us at McLaren to be innovative. We're not into following, and I know it's a very typical thing to say, we don't follow, we lead, but it really is the name of the game for us at McLaren because the competition, I mentioned earlier, is very, very tough outside in the automotive, all professions actually, but just to compete is not enough. I think if we don't bring something special to the market, something that really breaks loose the boundaries of design, we're really not doing our job, which is to really bring advantages to society. This car here is just basically an idea that we were preparing for 2025, and you will see it early next year as in one fashion or another. I can't be too specific about it, but it's something that we're looking at. And if you ask me, what is my inspiration? What is my view of the future? I really don't even look at the future. I don't believe in trends. I don't believe in something being fashionable, because what we have today, if we design for fashion or we design for trends, means that next year it will probably be out of fashion. It will be out of what looks good today. So there is almost an element of not being timeless when you design that way. For me, timelessness comes from everything that you see in nature. Nobody would ever think of redesigning the cheetah, for example. It's not that, it's not a beautiful object, and you would rather it look different, the legs should be shorter, or the neck should be longer, or anything like that. It is designed for purpose, and that is one of the key words that I feel is really, really important in terms of design, is design for purpose. You see a lot of designs, many different objects that look like they do something, but they do something else, and it's almost as if it promises more than what it can really do. My influences and what we believe in our design studio is that nature is really the mother of all creativity. That's where the real inspiration comes from, because it's optimized design over hundreds of thousands of years of evolution, and it does what it does best. So you won't find an animal that can go faster than a cheetah. Unless you looked under the sea, then you would see a sailfish, which is actually much faster than a cheetah. And the sailfish has to go through water, which is very, very incredible that it has this type of hydrodynamic resistance and can still go faster through it than a cheetah. I was in the Caribbean last year on a holiday, and I fell in love with the sailfish. We had a sailfish on where I was staying, on the wall, and I started looking at it after learning that it was so fast, wondering why it was so fast. And what I did was, when I flew back, I stopped in Miami and bought a sailfish, and we had it shipped, taxidermied and shipped, stuffed and shipped back to England, to McLaren. The first thing I did was send it down to the Formula One department, and we had it painted. Well, first we had it scanned, we had it tested for why it was so effective at what it was doing, and we learned that from the scales, actually the surface of the fish is not smooth like a car's surface. It actually has what we call diblets, little bumps and scales on the fish that make it it's regular but irregular at the same time. And what these scales do is they create little bubbles of air, vortices, that make the actual water that flows across the fish at speed not even touch the skin of the fish. It floats over or skims over the surface of the air on the surface of the sailfish. So it actually almost draws the fish forward, it pulls the fish forward, so it's actually going faster than it would go if it didn't have the smooth surface. on the surface of the skin. And then on the, very interestingly, on the back of the fins here, these type of indents or crescents or half moons are actually what give it its most hydrodynamic efficiency. And if you look at the Formula One cars, on many of the wings that they have in the front of the car especially, have this type of trailing edge to the spoilers and to the wings that give downforce and lift. And that is, as I said, you see it in nature. It's already something that's been developed over many, many hundreds of thousands of years to be optimized. Another influence that we're looking at is for example, from the birds. This is a peregrine falcon. It's not the fastest bird in the world. It's not fast horizontally, but it's extremely fast, over 300 kilometers an hour, diving straight down. And the way it manages to do that is to change its body structure and its position of the wings. It moves the wings forward and then backwards. Most airplanes that you see today have the wings going straight back. If you look at the way the bird flies, its wing structure, it actually moves the wings forward and then back. And that's what you see in the very, very latest new military technology for aircraft. They're starting to imitate and to copy this type of wing technology, and it's increasing the speed and the maneuverability of the airplanes. It's very, very interesting. And also what this bird does very effectively is it covers all its open surfaces and orifices to keep the air from coming into the actual bird itself. So it closes the beak area with a membrane, it closes it over its eyes, another membrane. And we're actually using this type of technology in future cars that we're looking at McLaren, where the body of the car actually extends in speed, takes another shape that's much more efficient aerodynamically. And also we are able to close different openings in the car so that it becomes much more aerodynamic at higher speeds. Like I said, a lot of our research and technology is coming from the industry of the aeronautical side, because they're not designed to look beautiful. They're simply designed for purpose. They're designed to be the most effective design possible. I think therein lies the beauty. I'm sure a lot of us think that military aircraft are fantastic looking pieces of design. Well, they don't have to sell them. They're not interested in making them look beautiful. They're interested in performance. So through this performance of making the objects extremely efficient, I think beauty comes out in that type of design language. Just almost to wrap up now, I think we've come a long ways. We've designed all through our whole evolutionary history. We've found things to help us become much more effective in what we do today. We hunted, and now we're back sitting down where we used to be. We're coming again much more lazy because machines are helping us. There's a little bit of a danger to this direction that we're taking now. I just don't want to put a negative spin on the way we're approaching with digital technology, computer graphics, and, or CGI, and different visualization techniques. But we have to be, as designers, very, very careful in the way that the future takes us, because it's our responsibility. We're the ones who are really leading the way in terms of what the world environment is going to look like around us in the next generations for many, many years to come also. And of course, we're going to be looking for ways to make life much more efficient, to give us more personal time, and we're going to be designing objects that help us around the house. Now, this robot, for example, is something that we can imagine very easily to be helping us in our daily chores, but I'm sure that nobody here would want something like this in our house, not because of the effectiveness of its purpose, but because it doesn't look good. Who wants a robot like this wandering around your house doing the chores that you would rather not be doing? So there is going to probably be a bit of a move in terms of designing objects around the house, like I said, that do these kind of tasks, but much more in a much more beautiful way. So that means that we're probably going to be seeing much more beautiful objects around us. And I know there are a few women in the audience today, so of course we're going to have to add a little bit of more excitement to that type of design. The problem with this is that if we're not too careful, then it goes a little bit further. We're going to have a little bit of competition as to what we'll be living with in the future. So we have to be a little bit more careful and a little bit more open to thinking out of the box. That's my real deep philosophy, is innovation and thinking out of the box. Find ways that actually benefit society, like I mentioned with the visionaries earlier, and it takes life in a very, very positive direction forward and creates a much more happier and satisfied world for us all. Thank you.